Now we are going to start with the property that is the reducing character. As you know that in a whole periodic table, the alkali metals are biggest of all. That means in their respective periods, they are actually the biggest of all. So that means they must be possessing low ionization energy, or they have the tendency to lose electrons, or we can say they can easily or readily lose electron, right. So these are the certain characters which make it possible to act them as a reducing agent. So as far as the reducing character is concerned, we know that it depends upon tendency to lose electrons, as I told you, and they will have tendency to lose electron, they will have more tendency to lose electron when they will have probably low ionization energy, and likewise they should have negative value of standard electron potential. Because we know that in this thing electrochemical series, we know that the one which have negative potential as compared to the SHE, they are actually they can actually lose electrons, and they act as reducing agent. So in that electrochemical series, all the negative ones are placed below hydrogen in middle, and above one are the with the positive values of the electrode potential. So that means the one which are present in the lowest one, they also include the alkali metals. So they are the three factors on which the reducing character depends. One is the tendency to lose electron. They will have that when they will have low ionization energy, and they will have low ionization energy that corresponds to the it means actually that they have negative value of standard electrode potential. So this is what the reducing character. So now if we apply this thing on the alkali metals, we have seen that like as we move down the group, as you all know, we have lithium, we have sodium, potassium, rubidium, cesium and francium. I am quitting this francium because it is radioactive, I told you in the previous topic also. So we will just look till here. So what happened? As we move down, we know that size is increasing because shielding effect is increasing as compared to that nuclear charge is decreasing. So that is why ionization energy is decreasing. So that means ionization energy is decreasing means that tendency to lose electron is somehow increasing. So that means if we compare lithium and cesium, the one which has the lowest ionization energy is the cesium. So that means it can act as a better reducing agent as compared to lithium. But what we have seen actually, we have seen that in aqueous medium, the order of their occurrence of their, or you can say the order of their reducing character varies in this manner. That means sodium act as the or you can say it act as least, it has least reducing character, and lithium has maximum reducing character, maximum. Means out of them, lithium is considered to be best reducing agent. So now what is the reason for that? As I told you, so that means lithium must be fulfilling all these things more as compared to the rest of the metals. So that means it has more tendency to lose electrons, it has more standard value of electrode potential, more negative value, and it will have the lowest ionization energy. So but we have seen that in this case, it obviously if we talk about ionization energy, lithium is going to possess the maximum ionization energy and cesium is going to possess the least one. So now what is the reason behind that lithium act as best reducing agent in its group? The reason is that this we see that the value for the electrode potential of the lithium is minus 3.04 volts. Now what is the reason that it possesses the maximum negative value? We know that maximum negative means that it is the powerful reducing agent. So this value actually confirms that it is a powerful reducing agent. But what are the reasons behind that why it acts as a, though it possesses the highest ionization energy, but still it is acting as a best reducing agent? What is the reason? So we see that the value of this electrode potential actually depend upon three factors. So energy of sublimation, ionization energy and hydration energy. Just look at the board how. Suppose I have lithium, we have in a solid form. If I want to remove electron from it, we know that we need to convert into gaseous state, because we can add an electron or we can remove an electron only when the atom is present in a gaseous state. So that means I have to supply it with energy that is equal to sublimation energy in order to make it, in order to convert it from solid form into gaseous form. So this is what I am doing here. I am converting lithium solid into lithium gaseous form, and here I need to supply it with energy. That energy is particularly called as energy of sublimation, and this energy is being supplied. So I will write plus delta H. That means I have given this energy to it, right? After this, now I have lithium in a gaseous state, so that means now it can actually lose electron. So what I am doing is, in the second step, I am just giving it energy. Again I am giving it one more energy, let us say it is H1, it is H2. I am giving this energy and it loses an electron, and this energy is actually called as ionization energy. So again I have given the energy, and lithium gaseous has lost one electron, and as a result it has formed lithium positive plus electron. Now after that, what I am going to do is, I am just going to hydrate it, right. So that means when I will dissolve in water, it will be maximum hydrated, and the energy will be released. Energy will be released, because we know that smallest is the ion, maximum energy on hydration is released. So what we see is that in first step, in second step, we need to supply it from energy from outside. That means these first two steps are endothermic, and the third step is the one in which energy is released. So what actually happens is that we know that any substance to act as a better reducing agent, or any substance to act as a most negative electrode potential, what should be the condition? The condition should be that the energy released should be more as compared to the energy absorbed. So what we see in this case, in two steps we are giving it energy, and in the third step energy is being released. So what we see actually, that energy release is much more, as compared to the energy it absorbs in the first two steps. So that means the hydration energy actually compensates the energy that is being absorbed in the sublimation and the ionization step. So that means the energy release is the maximum, and that is why the electrode potential is maximum negative, and that is the reason that it acts as a best reducing agent. Though it possesses the highest ionization energy, but still it acts as a best reducing agent. So if somebody is going to ask you that which is the best reducing agent in aqueous solution, you should quick with an answer that it is a lithium. Though it possesses the smallest size, though it possesses the highest ionization energy, but still it is the best one. The reason behind its value for the electrode potential, and why it is so negative, because it depends upon these three steps. So you need to explain these three steps. So I think you are clear that if we talk about reducing character, you know that how to answer it, right. So we will start with another property, that is the reactivity with water. So we know that if any metal wants to react with water, so that means particularly it has to reduce hydrogen. It has to reduce hydrogen, and as a result what we will get metal hydroxide, and there will be hydrogen gas. Now question is that do alkali metals react with water or not? Yes, they do, because they are very reactive and they are powerful reducing agent as compared to the hydrogen. As I told you that if we consider the series of that electrode potential, hydrogen is here and the negative elements are down. So that means alkali metals are down and hydrogen is placed above. And we know that the metal which is present low is the best reducing agent as compared to the one which is present above. So that means they act as a best reducing agent and they can actually reduce the hydrogen. And this is what they are doing here, and as a result they are forming metal hydroxide and they are forming hydrogen gas. Now if we talk about like what is the reaction for the alkali metals, so we have seen that lithium react gently, like means the reaction of lithium is not so vigorous, it has a gentle reaction. But if we talk about sodium, like if we add sodium to water, it actually melts on the surface. It actually melts on the surface, and sometimes it moves around and sometimes it catches fire also. But as we move down, the reaction goes on becoming so violent that potassium, rubidium and cesium often catches fire when we react them with water. Now the question must be in your mind that though the lithium is smallest in size, but it reacts gently, and if we talk about sodium, it melts on the surface, and we talk about potassium, rubidium and cesium, they actually burn, they get burnt actually. Now what is the reason? We can explain this on the fact of melting point. If we consider melting point, we know that lithium has somehow high melting point as compared to sodium, as compared to potassium, rubidium and cesium. So what happens actually, so like it has higher melting point, it has comparatively low melting point. So what happens when you add sodium to water, the heat of reaction is sufficient to melt the sodium. That is why it gets melted on the surface and sometimes it catches fire. But if we talk about lithium, when the lithium is added to water, the heat of reaction is not sufficient to melt it. Therefore, it reacts gently and its reaction is not so violent. So, if somebody is going to question you that why lithium reacts gently and why sodium reacts vigorously or more vigorous reaction as compared to lithium, you have to explain that we know that there is a difference in melting point of lithium and sodium, as lithium is smaller in size. So, that means it will have the higher melting point as compared to the sodium, and although we need to consider the heat of reaction also. So, when we add sodium to water, heat of reaction is sufficient to reach at the level of the melting point of the sodium. That is why it melts the sodium and reaction actually becomes faster. But if we talk about lithium, the heat of reaction is not too strong, or no, means though it is there, the heat is there, but heat is not sufficient that it do not reach the melting point of the lithium and could not melt the lithium. And we know that when the lithium won't be melted, or there will be no more you can say exposed surface, the reaction won't be violent in that case. That is the reason that it reacts gently. Right. So, this question is important, you need to remember that, and even the this thing, if we talk about this reducing character, this question is very important, that out of alkali metals which is the best reducing agent and how you can comment on that. Right. So, just look at a few more properties.